Okay, so to solve this one, we've got this plot here, and we'll need to use that HF, the energy of the photon, is equal to the work function plus the maximum kinetic energy of the ejected electrons. And then in this case, we've measured this kinetic energy by measuring the stopping voltage. So we will use this is equal to this plus E times the stopping voltage. Now, we've put the stopping voltage on the y-axis and the frequency on the x-axis. So we're going to want to eventually equate it to y equals mx plus b. So we want to make what's on the y-axis, v stop, the subject of this equation. So let's put EV stop is equal to HF minus phi. So V stop is equal to H over EF minus phi over E. Okay, so now what's on the y-axis is the subject of this equation. So we're now going to equate this to y is equal to mx plus b. And so we can see this is what's on the y-axis. This is what's on the x-axis. So this tells us that the gradient is equal to h over e, and the y-intercept is equal to minus phi on E. And what we're trying to find is, first of all, which one has the biggest work function. So to find that, we're going to have to look at the y-intercept. So that's literally where it intercepts the y-axis. So let's continue these lines along. This is just a sketch, not very neat, but gives you the idea. So that one went a bit wonky. But you can see that lithium is a big negative number, and the y-intercept is negative the work function divided by E. So lithium's going to be the greatest, followed by sodium, potassium, and cesium. So we'll have lithium for the work function. Lithium is greater than sodium, is greater than potassium, is greater than cesium. Okay, and then in the second part, part B, we were asked about H. So H on E is the gradient. Now each of these has the same gradient. So each of these, H on E is the same for each. And as E is constant, this means H is the same for each. So this means that the Planck's constant, which they give, is the same for each of them. So all equal H. Okay, so that's how you do that problem.